thought we'd do today is start to kind of basically pull off the training wheels, so to speak, and look at if we wanted to program something essentially from scratch where we're not following a template or tutorial or whatever, then let's sort of go through that exercise. And we'll just do a simple game here of tic-tac-toe. Nothing particularly exciting, but I think you guys will be surprised in both a good way and also a oh wow in terms of the kind of workflow that we'll have to go through, and also how seemingly something simple like tic-tac-toe actually does have some complicated it can get pretty complicated in the programming department. So right, okay. So tic-tac-toe, right? What all are we going to need? Well, we need to have um, a grid of 3 by 3 spaces of some sort, okay? And the players um, would need to be able to select one of those grids and change it from a blank square to either an X or an O, depending on which player they are. And in doing that, we also have to make sure that the player is selecting a valid square, meaning it can't be something that already has a shape in it, because that means that square's already been selected. So if the player tries to do that, we don't permit that. Okay. Um, and then we'll have to have something that basically keeps track of whose turn it is, so that we know when you select a square whether or not it should get turned into an X or an O. That would depend on which player it is. Um, and then the maybe the fundamental part of tic-tac-toe is, well, how do we know that somebody won the game? And for that matter, who won the game? Like, how do you tell? Yeah. Yeah, when there are three in a row, but there's 8 ways for that to happen, because it could be a row, there's 3 of those, there's 3 columns, and there's 2 diagonals. And that's just for one player, because it could also be the other way, in which case there's really 16 possible ways to win. Okay. And we have to basically check all possibilities every time that somebody makes a play. Okay, and then the final thing that is, at least with tic-tac-toe, this isn't true certainly about all games, but it is very possible and also happens quite frequently in tic-tac-toe that uh, you get a stalemate and nobody wins, right? Um, and so that will have to be something that we'll have to keep track of, that a no-win situation can and likely will happen. Um, yeah. Okay. So we got a lot of things to do, um, and it's going to take us, um, a while to go through this. It'll probably take us several class periods to do this. Um, if you were to sit down and just do it on your own, it wouldn't take as long, but talking through it is going to, add time. Okay. So the first thing actually that we're going to need is art, frankly, because we need to have sprites basically that represent the squares that can be selected, or the ones that are selected and have been turned into X's and O's. Okay, so we need basically 4 images, and we'll determine what size they need to be here in a minute. The default is 16 by 16, so we'll just probably run with that. But so I need to basically make 4 images: a blank square, an X, an O, and some sort of thing to indicate which square we're actually over, right? So like a selection box type thing. Okay. So the way I'll do this, and I'm just kind of picking this at random, is I'll take the pen tool and I'm going to expand the size a little bit so that it covers 4 pixels, and I'll make the blank just a white box. And I'm trying not to over paint it. And so this may be a little hard to see on the screen, but yeah, okay. So actually, it's even easier to see on the screen. It's hard to see on my computer. Okay, so just a white box, and this will be our blank tile art. Okay, um, and so I'll call this blank tile. Okay, now then I'm going to make 3 copies of it, and the first version, I'm just going to change and paint the outside yellow. And that's the one I'm going to use basically as like our cursor, if you will, to select which one's active. And then I need 2 players, so let's use uh, this sort of pinkish color as red, and then I'm going to paint an X in here. And try and make it look, halfway decent, which, we can debate whether or not it's halfway decent or not. I don't know. What do you guys think? Look okay? And then we'll do the same thing for this one. I'll paint the outside of it some other color, blue, and then we need to draw an O, and this maybe will be a little bit more difficult. So let's see. Does that look okay? Okay, fine, right? This doesn't have to be super fancy. Okay, so and then let's see. I need to change this image to we'll call this cursor. All right, so now that we got our art, we're basically ready to go. And so the on start, um, there's a couple things that I want to do to kind of modularize this, which is when you're programming, you want to take smaller pieces of code or a procedure for doing something and split them off into sort of separate little units that you could call when you need to do that, but you only have to call with one line, right? And then what is that code? Well, it's defined someplace else. Now, if you overdo this, it can get confusing to read your own code, but if you sort of do it judiciously, then it will save you some time. Okay, so on this game starting, what do we need to do? So once the game begins, what's the very first thing we got to do? Yeah, we got to get our tiles laid out here, all 9 of them in the appropriate positions, and then spawn the cursor and also, initialize any variables to be uh, something. We'll deal with that later. Okay, but let's deal with the putting the blocks into the 9 blank tiles onto the screen. Okay, and getting them in these sort of appropriate locations. Okay, so here we have to do a little bit of math, unfortunately, and so let's make a new kind here, and let's call it a tile for the thing. And then under the art, I'm going to pick the white one, our blank one to start. Okay, and okay, so maybe I should have actually made these things a little bit bigger than 16 by 16, but it's okay. We'll just run with it. Um, so I probably should have made them 32 by 32 just because, well, how big is the screen, right? It's 160 this way by 120 vertically. And so if I've got 16 pixel wide tiles and it's only going to be three wide, then I'm wasting essentially 70% of the horizontal area of the screen, and that's maybe not a good choice. So whatever, but that's okay. We'll just run with it. Um, okay, so I've got my tile here, and by default, it just spawns kind of in the middle of the screen. But I need to create all the other tiles. Okay, and the other thing I'm going to do is I'm going to name this tile one, and then we'll obviously have tiles 1 through 9. Okay, so so what I need to do then is, yeah, go ahead. I just called them tiles. Yeah. So the so I'm not using the tiles as in the tile map stuff. Now we could have done that actually. Okay, so we could have made, in fact, that might have been a little bit easier in some sense. Um, but I think you'll see um, as we get into this why it actually is in this case easier to not be using the tile map thing. By making essentially by making each of the things that you can select a sprite, uh, that will give us a little bit more control over like attaching data to them and some other stuff that you wouldn't normally need to with a tile and a tile map. So yeah, I just called them tile. They're not actually tiles. That's yeah, maybe not the best choice of naming convention, but whatever. Okay, good. So essentially, I need to duplicate this 9 times. Okay, and then uh, I'm going to have tiles 2, 3, and so on. Okay, and obviously this part gets a little tedious. All right, so there's 6, 7, 8, 9, and then I need to rename them all. Right, so a little tedious, but I mean, it's not rocket science. Okay, so I got all my tiles and they're all defaulting to the white thing and they are all of kind tile. Okay. Um, Now, at this moment, they all appear on top of each other, right? And so we need to move them to the correct locations so that we actually have a 9 by 9 grid. Okay, so for that, we need to basically set its position, the position of each one of these to something. Okay. Now we don't want 0, 0, so we have to kind of do some mental math here. Um, so there's two things about the sprite. So I just set that one to 0, 0, and you see how it's in the top left corner, but it's partly cut off. Okay, and the reason for that is that the sprites have. So if I go back to the assets here and we edit this one, okay, the origin for the sprite is actually in the middle, okay, not at the top left. And so the uh, make code knows, um, if you will, that um, the the tile is 16 pixels wide, and so if you want to put it at 0, 0, it's putting the center of the sprite at 0, 0, not the top left corner of the sprite at 0, 0. Okay, so that just means we have to, think about the math in terms of where do we actually want to put this thing? And so where is the middle of the screen? Okay, so the screen is 180 wide, or 160, sorry, and 120 deep. So the center should be at 80 comma 60. Okay, so let me put that first one at 80 60, and then let's kind of see what it looks like. Okay, and bam, it's right on top of all the other ones. Okay, so if the middle is 80 60, and they're each 16 pixels wide, then the first one should actually be um, at x equals 64, right? And y equals uh, 44, okay? 16 up in each direction. And then when it runs, and then we can see that it's perfectly lining up with the edges of the other ones that are at 80 comma 60. Okay, so now we just need to basically plop one of these guys for each of the positions of the tiles, and then just change the numbers accordingly, right? So the other thing we need to do is we need to choose a convention for where the tiles are. It doesn't really matter which way you count it, but wouldn't it make sense to do one, two, three on the top row, four, five, six on the second row, and seven, eight, nine on the bottom row? Yeah. Well, okay. I didn't think of it that way, but yes, just like the keypad. Okay. Um, now there's no magic to choosing that convention. You could have gone down, or if you wanted to like really drive yourself crazy, you could have just randomized them. But we'll just go with one, two, three, four, five, six in that order. Okay. So I need to just duplicate the positioning things, and then where do we need the second one to be? X coordinate should be 80, but Y should be 44, right? And then this one should be 96, 44, and that should be tile number 3. Okay, and then we've got the full row. Okay, so does that make sense? Okay, so now we need to do the same thing for the other rows, right? And this isn't, all that complicated. So let me just plop one of these in for all of them, and then we'll change the numbers and which variable we're doing. Okay, so let's see, tile 4. Where should tile 4 be? X equals 64, Y equals 60. Okay, and then X equals 80, Y equals 60, because that's the one that's actually in the middle. And then 96, 60. All right, and then we go back and it'll be 64, 76, 64, or sorry, not 64, 80, 76, and then finally 96, 76. And let's see. Oh, and then I've got to change the names. Okay, so this is tile 5, 6, 7, 8, and finally 9. Okay, so now we actually have a grid. Great. Um, okay, so you see that this is 18 little blocks of code, and it's kind of in the way of the rest of the OnStart stuff, right? So, because we're going to need to put other things in OnStart, like we're going to need to define some variables, we're going to need to define um, some we need to put in the cursor, we need to do all of those sorts of things. So what would be better long term is to take all of this and split it out into something else, okay? Namely a function. Okay, so a function, what is a function in math class? Yeah. Yeah. So a function in math class, you stick in a number and out comes a different number, right? According to some formula that you write down. These functions can be really super complicated. They can depend on multiple variables, right? But essentially, put something in, get something out. Okay, we use the word function in computing in a slightly more general way. Okay, that a function doesn't actually have to take in any input values or return anything. It can literally just be a placeholder for a set of instructions to be completed. Okay, so, oops, I'm not sure what happened there. Um, okay, so it can be a set of instructions to do something, okay? Doesn't have to accept input and it doesn't have to return output in this sort of mathematical sense. Um, and so what I'm going to do is make a function and I'll call this just generate tiles or something. Okay, then all 18 of those little blocks of code will go inside this, and anytime I want to create tiles and put them all in the appropriate spot, then I will call this function. Okay, now if I did want to have the function take in uh, information, then I would click on the appropriate thing here. So for example, I could make a function that takes in multiple numbers and then does something mathematical with them. Okay. Um, I can make a function take in things that are true or false. I can make it take in text. I can make it take in an array, which is like a group of similar types of data. So an array of numbers would be like a list of several different numbers. I can make it take in a sprite as an object, and I can also make it take in an image and do something with the image. Okay. Now, in our case, for this particular function, it doesn't need to have any inputs, so I won't put any there. But maybe later we will need some. Okay, and then I can plop all of this stuff in there. Okay, and if you click that little button, it will sort of hide the contents of it, which makes it easier to read your code. Okay, because it doesn't get, you don't have that big wall of stuff inside. Because we're convinced that once we've got this function working, do we really care about what's inside of it? No, we've got that settled. Okay, then now that I've created a function, I want to call that function in the routine. Okay, and from our perspective, it looks like everything's exactly the way it was. But what's happening is when you hit this blue block, it's sort of coming over here, doing everything that's inside there, and then returning back to where it left off in the on start. Okay, and I think you guys hopefully would agree that this is certainly a lot cleaner of an approach than just having one massive block of code. Yay? Nay? Okay. Um, and if you need to, so if I go back to the functions tab, right, there is the ability to return uh, numbers from the function. Um, in general programming, you can return any kind of object that you put in. MakeCode is slightly more limited in that it sort of seems to default to returning numbers, but or at least with user-defined functions. Um, that's not something that you have to worry about in full Python. But yeah. Um, oh, on the subject, next semester, right? Because it's you guys at registrations next week. Those of you guys who want to take more computer science, what should you take next semester? CS111. Yeah. Okay. Don't take 101. Yes. Okay. Good question. So 101 is essentially an introduction to CS as a discipline. This class is meant to, so the CS106, basically I created it in order to have an introductory computer science course that wasn't the same content as 101 because I was teaching 101 like every semester in a row for many years and I got tired of it, doing it every semester in a row. So, I mean, it's a full credit instead of a half credit. Um, there are some things that we look at. So, for example, I think we talked about data encoding with the sprites. So, for example, let me just go back um, here, right? How is this actually stored in MakeCode, this particular image? The way it's stored is with a paint by numbers routine. And uh, so let me go into the Python view here. Yeah, so you see these dot, dot, dots. Oops. Um, it's hiding this from us, but these images are actually stored as sort of an array of numbers, basically for each pixel, which of the 16 colors is it? Now, real images like out on the internet and stuff nowadays are not stored that way. That they're stored where with a red, green, blue, right? And so, but that's how you store images. How do you store numbers? Well, I mean, not really. Um, I mean, there's a couple things. One is everything's in binary, so you have to learn how to count in binary instead of base 10. It's actually really easy. Put your hands down on the table and have a friend chop off 8 of the 10 fingers, and now you can count in binary, right? Because then you only have 2 fingers instead of 10. No, actually, don't do that because that's, fingers are useful. But counting in binary and actually how you store numbers on a computer, uh, they're close, but they're not identical. And the fundamental difference is the computer only has a certain amount of memory. So computer arithmetic actually is more like working over z sub something for a very large something. And so it's cyclic in a way that like human arithmetic isn't. And that's just for integers. Floating point is a whole other ball of wax, okay? In terms of how do you store a fractional like 3.14? How do you store that in a computer? Um, it's not quite the way you would think of it. It actually works in kind of like a scientific notation system. So we look at a lot of that stuff. But the when I designed this course, I wanted it to be something introductory where you didn't have to have any background coming into it, but that when you finished it, you'd be ready for CS 111. Okay. So, I mean, I can't prevent you from taking 101, but it's probably better to take 111. So, yeah. Okay. So back to the code. Okay, so all we've really done now is just moved our tile generating into this function so that it's kind of out of the way of our on start routine and anything else that we're going to add in here. Okay. Um, so the other thing I need though is I need the player's cursor. Okay. And so I'm going to say, um, I'm going to make a new kind called cursor, and I'm going to name it. Um, oh, there it is. Okay. The cursor sprite to be the gold thing. Okay. So that's going to create a 10th object here, and you'll see it's maybe a little hard to see because I was stupid and made the art too small here, but The tiles are actually, or sorry, the sprites are sort of layered in order, and so um, since I put the cursor sprite after I've generated all the tiles, it's actually going to appear on top rather than underneath the other ones. Um, but that's okay. That's what I want. And so this is going to be the guy that I want to actually move around. Okay, now could we use the same movement tools or commands that we did when we did the space shooter to move this thing around? Okay, we certainly could. Should we? Why not? Exactly. How do you know which one? Okay, so the problem with the way that we handled player movement in the space shooter, or for that matter, the monkey game, right, is that it was continuous movement, right? That you could move the thing like one pixel over, and in terms of those games, that made complete sense. Okay, but in this situation with tic tac toe, we don't want to do that, right? We want to make it so that the cursor can only move an entire grid at a time. Okay. The other thing we need to do is to make sure that the cursor actually stays on the grid. Okay, it can't move off of the game grid, or else like that doesn't make sense. Okay, so those are the things that we need to add next is the movement for the cursor. We'll worry about the select in part later. Okay, but also keeping it within the confines of the game board. Okay, so it starts in the middle, and that's certainly a reasonable place to start it. Okay, but then we need to do stuff for the controller. Okay, now if I do move my sprite with buttons, okay, like this, then this is how we did it in the space shooter. Oops, it does help to, I was telling it to do the wrong sprite. Right, this is how we did it in the space shooter, and that's not what we want. Okay, so that's out. And so what we're going to have to do is a little bit more annoying. Okay, and we're going to have to do basically 4 of these. Okay, so I'll just lay them out next to each other because we'll have sort of some parallel structures. Okay, so what should happen if the left button is pressed to the tile or to the selector? Exactly 16 pixels, right? And similarly, if it uh, if we go right, we should increase the x by 16, and then for up and down, it's going to be the same thing, but the y coordinate instead of the x coordinate. Okay. Um, okay. So I'll do that. Okay. But then the other thing we need to know is should we move it at all? Okay, so let's take the left thing. And so what are we going to do? We're going to change its x position by negative 16. Okay, if you hit the left button. Okay, great. Oop, and it's cursor sprite, not my sprite. Okay, so that's great, except what happened? It moved off the screen, right? And now it's off the grid. Okay, I can't move it back because I haven't said what to do with the right button yet. We'll get that. But should this situation ever occur? Okay, so how do we prevent it from occurring if it shouldn't? Okay, right. That's basically the question, is how do we lock this within the grid? Well, how do I know if I should be able to move left? What is the x coordinate of this object? It's at 80 comma 60. Okay. So if the x coordinate is bigger than or equal to 80, that means it's valid to move the thing left. Yeah? So there we go. What we need to do is we need to have a conditional. Okay. So we need to say if something, then change the value. Okay. And what do we want to do? We want to compare the cursor sprite's x coordinate to a number. And what do we want that value to be? We want the value of it to be bigger than or equal to 80. Oops. Okay, so if the cursor has an x coordinate that's bigger than or equal to 80, that means that it is in the second or third column, right? Which means that we can move left because there's space to move into. If the cursor was in the left-hand column, its x coordinate would be 64, which is less than 80. And so this condition is not true, and therefore hitting the left button will do absolutely nothing. Okay, does that make sense? All right, so first off, let's test it and make sure that we can move left, but only so far. Yep, and so even if I mash the button here, it's not going to move left. Okay, so what do we need to do then for the rest of these three? Okay, so let me pause. Does it make sense how this is working for the left button? Okay. Any questions, preguntas, and or fragas on the left button part? No? Okay. What do we need to do for the other buttons? Same thing, except, yeah, it'll be the x values will go up and or it'll be y values that we need to change. The other thing is that the inequalities will change a little bit. And in the y coordinate direction, it won't be 80, but rather 60 is our threshold. Okay. So essentially, it's going to be four versions of this, but with inequalities flipped, y versus x, and some of the numbers change slightly. Okay. But otherwise, it's the same thing. Okay. So let's just duplicate and then change all of the bits. Okay, so right button should be less than or equal to 80, but change by positive 16. Okay, that's easy. And then up button should be, well, which coordinate do we want to change now? We want to change the y coordinate, okay, and let's make sure that we're clear here. What going up is doing what to the y value? It's subtracting because the coordinate system's backwards, right? Okay. And then what's the threshold beyond which we want to be greater than or equal to 60? Because that's the middle of the screen in that direction. And then we'll just duplicate one more time. And oops, this should be y, not x. And that should be y, not x. And we want this to be less than or equal to 60 and change it by positive 16. Okay, so basically the same thing, but just with some tweaks on numbers and swapping x's for y's and flipping inequalities. Okay, but in principle, does it make sense? We? Okay, muy bien. All right, so looks like we're good. I can move in any direction and I never leave the game grid Yeah, so it looks like we're good in terms of the movement. Okay, cool. All right. So what's next? Sure. Um, okay, so there's the up one. Sorry, what were you going to say? Yeah, we've got to implement the ability to select a tile and do an X versus an O. Okay, so we'll tie the selection to like the A or the B button, right? Doesn't matter really. Um, and that will should change the tile that's there with it to either an X or an O. Okay. Now, in doing so, how do we know whether or not to change to an X versus an O? Yeah, it depends on whose turn it is. Okay. And then also, what else matters? It can't already be an X or an O, right? So you can't change a tile that's already been selected. Okay. So we're going to need to check both of those things. For each of the tiles, we need to keep track of what state is it in. Is it an X, is it an O, or is it a blank? Okay. And then also, we need to keep track of whose turn it is. Okay. All right. So we need to make variables basically to keep track of this numerically. So it doesn't have to be numbers, but it maybe makes sense. Let's make the player turns either one or two, right? It's either player's one turn or it's player's two turn. Okay, that's easy. And then for the tiles, let's do the same sort of thing. Okay, let's make it so that a tile has a number attached to it. Okay, and that number could be, let's just say 0, 1, or 2. Okay, 0 means it hasn't been picked yet. 1 means that player 1 has picked it and it's an X, and 2 means that it's an O. Okay, and these numbers don't, like, I could have picked 4, 5, and 6, right? The numbers themselves don't matter, but you know, don't be an idiot and pick like 4, 7, and 36, right? That would be, I mean, you can, but why would you do that? Why would you do that? You would never do that. Okay, so how are we going to actually store this data? It's got to be someplace, okay? And the place that makes the most sense to store what state a particular tile is in is actually attached somehow to that tile, right? I mean, the other tiles don't care what the first tile state is. Okay, so what we need to do is basically tie data to a specific object. Okay, and we have a little bit of a hint for how we could do this because under the sprites, you see we can set or change their data and what pieces of data are able to be attached to them. Position, velocity, acceleration, friction, scale, and the scale globally. I don't see a create something here, do you? Basically, what I want to do is add something to this list, but it doesn't look like there is such an option, does it? Or is there? No? Okay. So what we're going to have to use is an extension to do this. Okay. And the extension that we need is called Arcade Sprite Data. Okay. Now, it doesn't look like that added anything, but it did. If we go into sprites and we go down to the bottom, we now have some extra blocks here uh, where we can attach data to a specific sprite. And the data, what we call this data, can be anything of our choosing. Okay. And the data type can be basically anything of our choosing. It can be uh, other sprites, it can be true false things, it can be strings, it can be numbers, and it can be images, right? Those are sort of the primitive data types in MACode. Okay, in our case, what we'll use is the numeric ones. Okay, so we have to do two things when we create this. We need to create the data and say, what are we going to call it and what is its starting value? Okay, so for each of the tiles, when the game is being played, what should their starting values all be for their state, if you will? They should all be 0 because we haven't done anything yet, okay? And we also need to choose what we'll call this, and so let's call it tile state, or even just state for short, whatever. Okay, now where are we going to put all this? We're going to actually have to put it here where we generate them, okay? And this is why it was nice that we spawned this off into a separate function, okay? Because now we don't have to do this for all of them, or do this, clutter up something else. Okay, so what I want to do then is under sprites, I want to set the data of a sprite, and I'm going to call this tile state to the number 0. Okay, now if I do it like I've got here now, and I change this, do I have to have 9 of these things? One for each tile, right? Set tile 1 to state 0, set tile 2 to state 0, set tile 3 to state 0. I could do that and duplicate this 9 times. Okay, and that'd work. That's fine. But I'm lazy. That's a lot of clicking. Okay, so there's actually another way that I can do this. Okay, so let me put this out here for a moment, and let me go into the loops. Okay, so in the loops can get used for a couple of things, right? They can be repeated indefinitely. They can be repeated a specific amount of time per, so like do this 9 times, okay? But there is also a primitive here called for-element value of list. Okay, so if I can create a list of every single tile, all 9 of them, then I can do something to each tile, okay? And that's what I want to basically do, okay? I'm partly doing this for sake of demonstration, and I'm partly doing it because I'm lazy. I mean, we could have just duplicated that block 9 times and been done with it, but this way we can see kind of how this loop works. Okay, so I want to do something like this that's going to go through and for every item in the list of tiles, do something to those things. Okay, so I need to create a list that has all the tiles in it. Okay, and fortunately, such a thing exists. I can get an array of all sprites that are of kind tile. Okay, this is why the kinds, by the way, is a really good thing to do in order to keep things separate, because do I want to do this to the cursor? No, I only want to do it to the 9 game tiles. Okay, now then for each one of these, I'm going to say, all right, so for element value of array of sprites of kind whatever, so what that'll do is the array of all sprites of kind tile will be a list of tile 1 through tile 9. And then this loop is going to go through and say, okay, I'm going to get out the first one out of this list. Okay, that happens to be tile 1. I'm going to set its tile state to 0, and then I'm going to move on to the next one. Okay, and so I've now done in 2 lines of code, or 3 if you count the little thing at the bottom, what would have taken me 9 the other way. Yeah? Okay, so this is one of those programming moments that's kind of like you guys know the meme with um, oh crap, what's that actor's name? Where he's like,
Oh,
you know what I'm
you're
talking
thinking
about.
of Great Gatsby, right?
No, it's
It's not Leonardo
no,
DiCaprio.
no, 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 not that one. That's the one where he's like holding a glass of let me find it.
Oh shoot, it was.
This one.
Oh,
Which actor is that? I'm blanking.
what is
Eddie
the name?
Murphy?
It's not.
Yeah, it's Eddie Murphy, I think. This one.
Uh, no, I think that's just a random guy. How do you spell
No, I thought.
It's just a random guy with
Okay,
a
well, he
glass.
sure looks like Eddie Murphy. I thought it was Eddie. Okay, well, whatever. But that meme, right? That's what we just did. Yeah. Actually, that would make for a pretty epic freshman tutorial on memes and just study memes the whole semester. Because there's actually quite a bit there that you could really dig into.
The
Um,
human psyche behind them.
huh?
Turn it into a bit of philosophy or psych class and how it impacts the everyone and how we like them.
Well, there's that, right? How do they impact human thinking? But also, sort of like, where did the term meme come from? So, believe it or not, it wasn't like from 4chan or some dark, seedy corner of the internet, right? The term meme is actually like 50 years old, and it was I want to say it was Richard Dawkins that came. And essentially, what he was trying to do was come up with a term to think about a unit of information transfer in the same way that a gene encodes biological data. Maybe there's like a unit of information like thought data. Now, what I don't know is how these got attached to the images that now are all over the internet. Like, why is it we call those memes? But we do. Um,
I guess it is a transfer of information.
it is, but like somebody had to be smart and know that term to and then say, hey, that's what we should call these images that are floating around on the internet, and then everybody else had to do the same thing. Because I mean, you guys have probably all used the word meme and not realized that it actually is a term that predates the internet, which I know is sort of a frightening concept that things predating the internet. But yeah, um, do you guys remember life without the internet? Because they're probably all too young. How many of you guys had dial-up modems when you were kids? We had to use the telephone line to connect to the internet. Didn't that suck?
It took
It
me
was
forever.
slow. Yeah, so slow. Um, yeah. So yeah, I remember when uh, I first started using the internet. It was through AOL, right? And you had like a number of minutes per month that you could use, almost like long distance, right? Uh, it was, you had like 300 minutes a month, and you thought, oh, this is tons of time. And then you try and download something, and it takes for freaking ever. And yeah,
Uses all your minutes.
uses all your minutes, or you get yelled at by your parents for going over the minutes pile, and then there'd be like an overage charge or whatever. And yeah, good times, good times. And may we never see them again. Um, okay, so um, right. So what we've done there is think smarter here. Okay. Now, just for sake of demonstration, okay, I wouldn't actually do this, but I'm going to have each of them say their tile state. Oops. Okay, so what I just basically did was tell it each of these 9 sprites to make a little text bubble, speech bubble, and put the number there that corresponded to its tile state. Now, right now, they're all zeros, okay? But that's what they should be because that's what I just set them to. So adding little things like this, I'm going to pull this out immediately, but adding little things like this can be good for debugging and also making sure that things actually are working the way you think that they're working. Um, so, do stuff like that to just to basically it's a check for your own sanity. And if I change the numbers to something else, because you might say, oh, well, zero is a default value, so let's just make sure. And yeah, in fact, they are all 5. Okay. So now I know that they're all correctly getting set to whatever. Okay. All right. So is it okay if I delete this now? We? Yeah. Oh, it's because it's actually it the speech bubble goes above it. So you see how this top row speech bubbles, that's actually from the top row, and so everything's shifted. That's just the way the speech bubbles are the art for them goes. Um yeah. Uh okay, good. Yeah. Okay. Hmm? About to. Well, I mean I can, but oh, the thing to do it. So the it's in sprites down at the very bottom. I wanted this one, item data as number. Okay, so item would be what object is it? Data, and then the thing in quotes would be what if I called that data object, and then as number because it's a numeric piece of data, not a text or something else. Okay. Yeah, so there's 2 things about that. One is you'll notice that everything is, for the most part, color coded, right? So things that are in this dark blue color are all in the sprites menu. Okay, so that's thing number one. And then the other thing is, so what's the difference between this roundy version and these 2 guys? This roundy version is just accessing and using that data. These 2 here change or set the number to or the thing to a particular value. So depending on what action you want to be doing, you use which of the 3 blocks that's appropriate. Okay, and then the rest of them are basically the same thing. It's just for the other data types, which we're not going to use here necessarily, but that's okay. Okay, good. All right, so let me get rid of that and change this back to 0. Okay. So the next thing we've got to do is we need to the variable for the player's state, like whose turn it is. Okay, and the that should start for sure. Um, I'll make player turn a numeric variable that can take on the values 1 or 2, and I'll use here 1 to indicate um, that it's um, player one's turn, and 2 to indicate that it's player two's turn. Okay, that certainly is logical. Okay, now I'm going to make, just kind of thinking forward a little bit here, I'm going to make another one of these variables for the game state. Okay, and if we just think about tic tac toe, what game states are possible, right? So, what state could the game be in as we're playing it? Or what states, plural? Okay, now if we start to enumerate that, right, how many different states are there that the game board could appear in? Well, that's going to be a crap load, right? Because it's actually going to be 3 to the ninth. Okay, why 3 to the ninth? Well, how many states are there for any individual tile? Three. Not picked, X or O. How many tiles are there? Nine. And, well, okay, so it's actually slightly less than 3 to the ninth, but what is 3 to the ninth? Just Google it real quick. Or, hey Siri, what is 3 to the ninth? 19,683. Do you want to enumerate all of those? I don't know about you guys, but I'm lazy. That's way too many. Okay. So let's think, maybe redefine what I mean by state, okay, of the game. Well, the state could be 0, meaning that the game is currently being played. But it's tic-tac-toe, so what eventually hopefully happens? It ends, and how can it end? In three possible ways. Player one could win, player two could win, or it could be a stalemate. Okay, so let's make a variable called game state. We'll set its initial value to 0, but then we'll set it to 1 if the first player has won, 2 for the second, and 3 in the situation we get a stalemate. Okay, um, and then the last thing that we need to worry about is, well, how would we even check if there's a stalemate left to be done, or that if there is a stalemate? Like, how do we know that that has occurred? Okay, so you can think about it that way. If it's not 3 in a row, okay, but when the game starts, there's not 3 in a row. Exactly. Okay, when 9 tiles have been changed, or a different way to think about it would be when the number of available tiles to select is 0. Okay, it's just which way do you want to think about it? Okay, so let's also add in a variable for how many tiles have been selected. And if that value ever hits 9 and there's not a winner, then we know that we're in a stalemate situation. Okay, so then every time that we pick a tile, we'll need to increase that number by 1 so that it will eventually hit 9. Okay, and maybe it'll hit 9 and somebody will win. Maybe it'll hit 9 and nobody will win. But we'll know that that's happened if we have 9 picked and not a winner. Okay, we also still have to program in the how do you check if there's a winner situation. Okay, which will take a little bit of work. Okay, good. We All right. So what variables did we say we wanted to do? We wanted to add one for game state and tiles picked. All right. So I'm going to set tiles picked to 0 because at the beginning of the game, nothing has happened. And I also want to do, what was it? Set game state to 0. Okay. And I'm going to use game state 0 here to mean that we're currently playing the game and nobody has won. There's not a draw. We're still playing the game. Okay. So in the situation, excuse me, that somebody's won, we'll switch the game state to the appropriate value, 1 or 2, depending on which player it was that won. And then if we've detected a stalemate, we'll do game state 3. And then we can use those 3 numbers to indicate to us, like, uh, what kind of like game over menu do we want to have, or game over screen, right? The game over screen, we actually probably want to have 3 of them. One that says player 1 wins, one that says player 2 wins, and a third one that says stalemate. And then we want to reset the game and start everything over. Okay, so make sense? Yeah. Okay, so got those values set, and so let's see what do we need to do next. We need to handle tile selection. Okay. All right. So we need to, in order to handle tile selection, we need to know which tile is the cursor over. How can we tell that? Couple of ways, right? We know which cursor or which tile we're over because we also know their coordinates, okay? The other thing, how did we do this in terms of like the space shooter game and stuff like that? We had these guys here, right? So we can have a thing here that says if we overlap with with a tile, then we can do something, okay? Um, Similarly, we can ask, is it the case that the cursor is overlapping with a specific sprite? Okay. Um, all right. So let's think about which one of those might we use. Okay. The other thing is let's look in the controller menu here because I can do an event for is a button pressed, and I can also have a true false thing for if a button is pressed. Okay. So let me actually use the overlap thing. Okay. And let me come over here and make some room. Okay. So I want to know whether or not my cursor is overlapping a tile. Okay. And if that is true, then what do I want to check? Right. If there's anything there already, but also whether or not the player is trying to pick it. Okay, so I should trigger an action within this only under the situation that um, it is that I've actually hit a button, like say the B button. Okay, and so I'll have to use an if condition. Okay, and under if, I'm going to check is the B button pressed or A button. It doesn't really matter, right? Okay. Now, what should happen if I am over a tile and the button is pressed? What should be true? What should happen? Yeah, it's going to place an X or an O at that thing. Okay. Um, but the this should only trigger under the situation that um, that the tile has not already been selected. Okay. So what needs to be true about other sprite? So let me get a couple of blocks in here, and then let me build this statement up. Okay, so I need to make a compound statement like so. Okay, so what should be true for me to be able to select a tile? Well, I need to be trying to select it with a button. Yeah, its state needs to be equal to, that's not what I wanted. Sorry, sometimes these things can be a little bit tricky in terms of, there we go. Okay, so what should what was the object tile state as number should be a 0 to indicate that the thing is selectable? Yeah? Okay, so let's think about what I've built up here. So I am doing a logical and between two conditions, right? The first is that the button actually has to be pressed. If the button's not pressed, then who cares? And the second is that the thing that I'm overlapping with his tile state had better be 0. If it's not 0, then that means it's already been picked. Yes? Okay, good. Okay, so that's the condition that I need to check. And then I have to decide what to do based on that, which I think we're going to run out of time. But yeah, so let's just make sure. Are we cool with that that compound thing? And you guys saw how I kind of had to build it up from multiple pieces and get everything socketed correctly. This is mildly annoying because the sockets sometimes pop in where you don't want them to go, but just if you fiddle with it, it'll eventually you'll get it. Okay. Um, so the you see how I built it out of two things that were sort of pointy shapes, right? The mate code treats anything that's got little pointies on either side. Those are things that can only be true or false. Okay, and that makes sense. The button is either pressed or it isn't. Okay, and the tile state is either equal to 0 or it isn't. Okay, so the pointy objects are booleans, is what we call them, meaning they can take on the values true and false, and that's it. Okay, and I can combine booleans together using logical operators, one of which is and. Okay, and so if I click on the and here, I can see what the other ones are. Okay, um, there's basically, well, two primitive ones, but you can build more out of it. So you've got and or. What's the difference? Yeah, and possibly both, right? So if I ask you, for example, are you in computer science class or a math class? You would all answer true to that because you were in this class, regardless of whether or not some of you happen also to be in math classes. Okay. If I said, are you in computer science and math? Then not all of you are going to raise your hands, right? Some of you will because you're in both math and computing, but not all of them. Okay. Now, the word or there, and that's actually maybe a good thing to quit with today. In English, actually has two senses. Okay. So if I ask you, are you in math or computing class? You recognize just from the question that the possibility of both is completely reasonable. Okay. All right. So let's say that I go visit my parents and my mom asks me if I want to have vanilla ice cream or chocolate ice cream for dessert. What's the intent of her question? Yeah, which flavor of ice cream do I want? If I respond with both, what's probably going to happen? No, you don't get both flavors of ice cream. You don't get any damn ice cream. Go to your right. I mean, a little old for that, but point being, the word "or" in that sentence has a different meaning, right? The meaning there is that both possibilities are not. That's not a valid option. It can be one or the other, but not both of them. Okay, and in computing, we call this exclusive or XOR for short to mean that it can be one or the other, but not both. And that's different than just regular or. But regular or here means that both are possible. Okay. Um, and then you can, using and, or, and not, which is another thing there, you can build up any of the other more complicated logical expressions. Okay, so in our case, though, and is what we want because we only want to do this under the circumstance that both things are true. Okay, so that's when we want to do it. What we'll start with at the very beginning next time is what do we then want to do? Okay, all right, so does this kind of make sense, this thought process? We? Okay, so if it wasn't clear, the monkey thing with your, and we're going to do it, same way with the space shooter. Finish it, and then add something cool. Okay, and something cool, I will leave it to uh, you guys to define. And I'll post it to Canvas. And I'm sorry I forgot to do that. So, all right, see you guys Tuesday.